Hi scientific audience. So today we'll be discussing the continuation of the Coulomb's law in the vector form. So here we have three charges Q1, Q2, Q3, and we are supposed to investigate the net force acting on charge Q1, and we'll be also writing that in the vector form. So this is, in this current situation I have only taken two charges, but in the next situation I am going to take multiple charges Q4, Q5 till Qn, and then we are going to formulate a equation in the vector form of the Coulomb's law. We know that Coulomb's law acts along the line joining their centers, and we also have discussed previously that the position vectors are must needed in these kind of situations, and position vectors head should be towards the charge and the tail of the position vectors must be towards the origin. So origin of the coordinate system is shown by O. Q1, Q2, Q3 are the charges, and we are considering all the charges positive for our convenience over here. You may take any other negative charges as well. It is not going to affect our equation. So since this is the line joining Q2 and Q1, and we know that the Coulomb's law is a central force which acts along the line joining their centers. So this is the line joining Q1 and Q3. Now I am supposed to investigate the forces acting on Q1. So since both the charges are, all the charges are positive, Q2 and Q3 are going to apply repulsive force on Q1. So Q3 is going to push Q1 along this direction, and as discussed earlier, this is referred as force on 1 by 3. In the same way, force on 1 by 2 will be in this direction. Force on 1 by 2. Now we can well assume, as per the triangular law of vector addition or the parallelogram law of vector addition, that the resultant force would be in this direction, right? But we need not to find out that right now. We'll just write the equations of F12 and F13. So force on 1 by 2, that is equal to 1 by 4 pi epsilon 0, assuming all the charges are in vacuum. Then we have Q1, Q2 upon the distance between them, Q1 and Q2, is represented by R12 vector. This vector whose head is towards Q1, this vector is R12 because the position vectors of all the charges are written over here. So as per the vector addition, this is R12, and if you have forgotten, I must say once again that R12 is equal to R1 vector minus R2 vector. Alright, and the direction of R12 and F12 are same, right? So F12 is 1 by 4 pi epsilon 0 Q1 Q2 upon the distance between Q1 and Q2 is R12 vectors modulus whole square, and since this side is the vector, we need to assign a vector over here that should be a unit vector. So we know that R12 is a unit vector along F12. In the same way, guys, I can also write down F13, force on 1 by 3, that is equal to 1 by 4 pi epsilon 0. Then Q1 Q3 upon R13 vector whole square and R13 vector unit vector, right? Now if we move on to the next slide, here I have shown multiple charges Q2, Q3, Q4, Q5 dot 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 till Qn. So there are n charges, and the distance between all the charges, since we have already discussed that this distance between Q1 and Q2, since the arrow is pointing towards Q1, it is R12 vector. So this is R12 vector. In the same way, this is R13 vector. Guys, I have not shown all these arrows again in order to make the diagram more clear, because now you have understood that this is R1, R2, R3. So I have not shown once again over here, correct? This is again R14, and this will be R1n vector, right? And Qn, since all the charges are positive, Qn would be pushing Q1 in this this direction, and this force will be F1N. This we have already seen that this force is F13. This is F14. This will be F12. So now if I write the net force acting on the charge Q1, so I should write down F net, that is the force acting on charge Q1, right? So the force acting on charge Q1, that shall be equal to F12 plus F13 plus F14 ... till F1N. Guys, you might be thinking that the sequence is correct, but why there is not F11? Because we understand that the charge 1 cannot apply the force on itself. Now, writing these, because we already know what is this. This is 1 by 4 pi epsilon 0 Q1 Q2 upon R12 vector whole square and R12 unit vector, correct? In the same way, this is plus 1 by 4 pi epsilon 0, then Q1 Q3 upon R13 vector whole square, then R13 unit vector. In the same way, I'll only write down two more terms, one for F14, so that is again 1 by 4 pi epsilon 0 Q1 Q4 upon R14 vector whole square and R14 vector unit. In the same way, the last vector, that is F1N, you might have guessed it correctly that it is 1 by 4 pi epsilon 0 Q1 Qn upon R1N vector whole square and R1N unit vector. Now guys, if I want to pull out something common, then what can that terms be? 1 by 4 pi epsilon 0, that is common. Then Q1 is also common because Q1 is appearing in all the terms, like here Q1 is there, here Q1 is there, Q1 is there, again 1 by 4 pi epsilon 0 Q1 is there, so that's why I have pulled it common. Now what stays inside is Q2 upon R12 vector whole square R12 cap, then again I should write down Q3 upon R13 vector whole square, then R13 cap ... So guys, writing it in continuity, this is plus two more terms, just in order to generalize, it will become more easier. So this is Q4, this is Q4 upon R14 vector whole square R14 cap, till the last one was Qnth charge upon R1n vector whole square and R1n cap. Now if you want to generalize this one, then it can be written as 1 by 4 pi epsilon 0 Q1 sigma, this is F net force on, so sigma, and since there are numbers like Q2, Q3, Q4, Qn, so I'm going to write this as Qi, and here since the first term is remaining the same in the R12 and R12 cap vector, R1, R1, the first one, so I'm going to write this as R cap 1, then same number is repeating over here, 2, 2, 3, 3, so here I, correct, and the same vector is appearing in the denominator, R1 I vector mod whole square. Now the value of I starts from 2 to n, because the first charge does not apply force on itself. So here the value of I is 2, 3, 4 and so on. So hopefully guys you have understood this one. This is our final answer. Let me highlight it, and this is a consequence of the parallelogram law of vector addition. So if you have not understood any of the step, guys, you can please put up your comments. Thank you for watching the video.